Hey everybody, welcome back. So we looked at our conditional probability in our two-way tables. Now we're going to look at intersections and unions. So the probability of an intersection between event A and event B means that the probability that both are true at the same time. So we were kind of already looking at that here. That was the numerator like there. The probability that they didn't have the disease and test positive. And that is written either P of A and B, or a shortcut is this symbol. This symbol means and. And how I remember that is it's and, that symbol's kind of hiding in the N, right? And B. A union is the probability of a union between A and B means the probability of the event A occurring, event B occurring, or both occurring. And it's written P of A or B. B, which has this U in the middle, which I remember because union starts with that U. So and, or, and, or. And the union of events is calculated that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And that feels a bit weird to subtract this out, but you're going to see that if we don't subtract that out, we're going to be double counting. Because if we count everything that happens in A and add everything that happens in B, well, if we've got things that happen in both A and B, we've counted it here and here, and so we have to subtract one of them out. So, let's start with completing this two-way table. So, maybe you're a marketing company and you're running some commercials, commercial A and commercial B. And then you're checking, okay, you check it by, maybe you have, your 80 people who watch the commercial, and you say, which of you would buy the product based on the commercial, which of you would not buy the product based on the commercial. So you're kind of trying to compare the effectiveness of the commercials. So, total who would buy the product based on either commercial is 22 plus 26, or 48. Total who watched commercial B, right? Not everyone watched both commercials. Commercial B, there were 40 people who watched the commercial, so they seemed to split it evenly, which means there were 40 people who watched commercial A, which means that is 18, and that is 32. Again, it's all addition and subtraction using rows and columns that does this stuff. So, the probability that someone in this focus group watched commercial A is just going to be, okay, how many outcome of people who watched commercial A, 40, out of the total, 80, is 1/2. So half the people watched commercial A. What's the probability that someone would not buy the product? Well, 32 wouldn't buy the product. There are 80 total, so 32 out of 80. Those can be both divided by 8 to start, which is 4/10, or 2 out of 5 wouldn't buy the product. Which, just as a reminder, that means 3 out of 5 would buy the product. All right. Now we get into our new stuff. So the probability, I guess I still need to see my table, that they watched commercial A and would buy the product. So this is still out of this isn't like conditional probability. This is still out of our total of 80. But out of those 80, 22, well, I look, commercial A is here, would buy the product that's here. Here, let's highlight, bam, our intersection is here. There are 22 out of those 80 who watched the commercial A and would buy the product. Let's divide that by 2, and we get 11/40. Then, draw a little dashed line. Oh, gosh darn it. Okay, next is how many watched commercial B and would not buy the product. So this time I'm looking at commercial B, which is that row. Sorry, having some pen difficulties. Oh, apparently not. This row here, and would not buy is this column, so our intersection is 14. So that's going to be here. I'm going to write it here. 14 out of 80, or 7 out of 40. Now we get to the union. Here's where I'm going to talk about the double counting a little bit. So what's the probability that they would watch commercial A or would buy the product, which means or both. So how many people watched commercial A? 40. How many people would buy the product? 48. Well, as you can see, we're literally we are already over 88. We're at 88, which is more than 80. And how can we have more people than our total? The issue is when we count that all these people would buy the product to find that 48, and we count that all these people watched commercial A, the issue is these 22 people were counted in this total and in this total, and we only want to count them once instead of twice. So what we have to do is we have to subtract out that 22. So that means, because really what we're doing is we're adding 22, 26, and 18, but this is kind of our shortcut. So 40 plus 48 minus 22 is going to be 66. That is smaller than our total. That's going to be 66 out of 80, which is 33 out of 40, which is as far as you can go. Our next union, look at that U, looks at how many watched commercial B or would not buy the product. So that's going to be commercial B or would not buy the product. So you could add this, and this, ignoring the totals, just add the parts, and that would get you the same answer, or you could add these totals and subtract the intersection. Subtract where they're both true. I'm going to add these totals. 40 plus 32 is 72. Minus 14 is 62, 58. So, gosh darn it. I'm having technology troubles. So I know that 58 out of 80, or 26 out of 40, not 26, 24, no, 29. Yeah, it's been a long week. 29 out of 40 are either in commercial B or would not, or watched commercial B or would not buy the product, or both. Now we're getting back to conditional. How many watched commercial A given that they would not buy the product? So I look, there are 32 who won't buy the product. Of those 32, 18 watched commercial A and would not buy the product. So it's going to be 18 out of 32, which is 9 out of 16. How many would not buy the product given that they watched commercial B? Well, 14 out of those who watched commercial B wouldn't buy the product. And how many people watched commercial B? Well, 40 of them. So 14 out of 40, or 7 out of 20. So who else might be interested in these results, which might be the most interesting for them. So again, this is like, it's a bit weird because maybe you're kind of, what I'd be assuming I'd be doing with this data is deciding whether commercial A or commercial B were better for getting people to buy the product, but you could also be, maybe you're kind of doing it proportionally because commercial B does look better, but maybe you're already airing commercial A and it would cost money to produce or finish producing commercial B or something, who really knows? And so you see, given those who wouldn't watch more come in commercial A than in commercial B, it just gives you some data to look at if you are into marketing. And you think of the other probabilities we did. So this one would be great if you're looking at marketing. This one's really useful in the pharmaceutical and medical field. Things like this are really regularly used. Things like this, I don't know, maybe in a social science study or some kind of survey could be used. What was our other one? What was up here? This could be another this is probably another marketing one. But these, conditional probabilities, they pop up a lot. And the unions and intersections pop up a lot. They just appear a lot. They don't always appear in these two-way tables. It's just a really neat way to organize the data, in my opinion. It really helps you just kind of see everything. Next week, what we're going to be looking at, as a little preview, is we're going to be looking at a way to organize a table in what's called, Venn diagrams. So next week we're going to be looking at, like, how does this work? How do I know that this is the intersection and that, like, the whole thing's the union and weird things like that. So, thank you for sticking with me. I will see you next week.